Hello tutor, my name is Mahir, and in this video I'll be explaining my solution for the practical task 6.1p. So this task was all about polymorphism in C hash language, and the aim was to create a base class called bird and two subclasses called penguin and duck. So then I had to show how different objects behave differently when we call the same methods on them, and then also demonstrate something called covariance with collections. So we'll just quickly go line by line of our code. So first of all, we had the bird.cs base class. I'll just quickly write it through all the code line by line. So first of all, I started with the base class, with the bird class, sorry. Um, as you can see, it has a public property called name, which stores the name of the bird. As you can see over here. Then after that, I created a virtual method called fly um, over here. So sorry, the first line that we had to create the bird class, the public property was the name, which stores the name of the bird is over here. And then as you can see over here, I created a virtual method called fly. Um, the reason why I made it virtual because I want uh, child classes to be able to override it later if they you say behave differently. So uh, just by default these methods just print flap flap flap, as you can see over here, or for a normal bird. So at the end, I overrode the into um, build into string method, as you can see over here. This means that when I print a bird object, it shows a nice, I mean, I can say readable description like um, you will see that in the output that a bird called feather instead of just showing me the class name. I hope that you can understand that. Then we'll just move on to the penguin base class. Sorry, it's not a base class, it's a subclass. And then yeah, I created this penguin class, which it inherits from the bird class. So in this class, I overrode the fly method because penguins can fly, as you can see in my code. So when we call the fly method on a penguin object, it will print something like penguins cannot fly. That is obvious. Instead of the default flapping message, sorry. And I also overrode it to string method so that the penguin prints something like a penguin named um, happy. I can say happy feet when it's displayed. And we'll just move on to the our next subclass, which is duck. So I created the duck class as it also inherits from the bird base class. So ducks have I can say extra details. So I added the two properties for that. So first one is the size property for the it showcases the duck size, and the second one is the kind property for the type of bug for the type of duck, for example say mallard or decoy, that I've called that in the program.cs file. And then at the end I overrode the toString method to include this extra information. So for example, printing a duck object gives something like a duck name, uh, say Daffy. I've written Daffy is a 15-inch mallard. So, like since ducks can fly normally, I didn't override the fly method as I did in the other subclasses because they use the base class implementation which prints flap 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 as in the but subclass. And lastly, we'll just move on to our last um, main method, which I've named program.cs. So it is the main logic of the program. So first, what I did is to create the ducks. I first created two ducks, as you can see, Daffy and Donald. So Daffy um, just points out to a 15-inch mallard. It's a type of duck, and the Donald is a 20-inch decoy. which is also a type of duck. So step two that I did was to put ducks into a list, duck one and duck two. I stored both ducks in a list which are named duck. So, and it's called ducks to add, as you can see over here. And the next step is what brings us to covariance. So I find this part particularly interesting, and because I assign my list of the ducks to I enumerable bird um, um, variable. So this works because of, I can say, covariance, especially because it lets us create a collection of ducks as a collection of birds without copying the main data. Sorry. So my next step was to create a list of birds. As you can see over here, I've created a list of birds and then added um, one normal bird called Feather, and then one penguin named Happy Feet, as I was explaining in the subclasses. And then after that, I added all the ducks into bird list. And what I did in that is I used the to add range method to add both ducks into the main birds list using the covariant I enumerable bird variable. And the next step I did was finally looping through the entire birds list and called the um sorry toString method that prints a description of the bird, and then a fly method that calls a write implementation based on the actual object. So like even though the list type is bird, the behavior changes at runtime. So say for a normal bird, it prints flap flap flap, and for a penguin, it prints penguin cannot fly. And for a duck, it uses the default flap flap flap, but the toString method is overridden to show size and kind. To showcase what I just said, we'll run the program. Yes, so as you can see, in the output bird list after the addition of ducks, which is a covariance demonstration, a bird called Feather, and flap flap flap, a penguin named Happy Fleet, penguin cannot fly, a duck named Daffy is a 15-inch mallard, and flap 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 again to override that, a duck named Donald is a 20-inch guy, and at the end flap flap flap, and we just exit the code. So this matches like exactly what the task expected. It shows I can say the same methods behave differently depending on the actual object type. So yes, so this was the demonstration of Mata 6.1p. I hope um, I have met the expectations of the demonstration. Thank you so much for watching the video.